Seems a bit ridiculous. Ain't nobody got time for that. Okay, you need to have out your math workshop, but more importantly, you need to put your phone away before it gets you in some trouble. I'm not in the mood. Lord knows how you did on that piecewise quiz. Not going to lie, a lot of people's broke my heart. So that means we spent days and days and days of me talking about piecewise. And I had someone this morning in zero period, well, I just don't understand, Miss Compton. Can you just go over it again? I've been over it 5,000 times. So either Patrick's not listening. No, it's not Patrick, but I can pick on Patrick because he's nice. Either Patrick's not listening to me, Patrick's not paying attention, and he's continuing to play on his phone even though I've already asked him. I'm about to lose my temper at you, child. You feel me staring at you. I'm about ready to go. Let's do this. I get to hold it. Thanks. Shouldn't have been on my nerves. Okay, let's see. So am I supposed to monitor you better and say, Will, it's math class. Why don't you have math out on your desk? Then why is Will an out for 2 or 3? He doesn't need to be in this class with me if this is the conversation we're going to have. He doesn't. And let's be honest, I'm assuming that quiz reflects that. Because I had some people on their piecewise quiz who genuinely drew no fence, had no fence points, just had a line.
At this time,
What is that?
We have freshmen M through Z who need to make up or retake pictures. M through Z to the lobby.
What is that? Your group's going to end up with all the negative points if you can't start finding some math to get out right now. Okay. So, meanwhile, we're going to move on from that. Piecewise is sadly not over. We've got to eventually test on it, but there are 2 more sections. My God, we pray we get those 2 sections better than we did piecewise. That way we do well on this next test, because while that quiz is only going in the 30%, there is a test coming up next week that's going in the 60%, and yes, there are piecewise questions on it. Go ahead and take it to a -2. Okay, you need out your note packet as well. We are actually going to go out of order today. So I didn't want to do parent functions next. Instead, I want to do graphing inequalities, which is on page 37. So if you want to flip to that, it's like 2 pages from the end in your giant packet. 2 pages from the end in your giant packet. Yes. Okay, and then let's go ahead and go over these math workshops so we can get to these 2 pages. And if you didn't read the board today, you also have a checkpoint on this new section, so you better make sure you pay attention. Okay, number 4, Natalie would like to volunteer. Go ahead, dear.
Non-x parentheses -4x plus 2.
The bigger number than 9. 18. If you can pull out an 18x, and then what would you be left with? -18 times 4 is 36. -2x plus 1. And that would be correct. And we'll give Natalie a point. We'll also give Eduardo a point for helping her out. And that answer is completely okay and correct. But there is another answer that is also sufficient and acceptable. Any thoughts on that? Well, Natalie was wanting to factor out a 9. And 9 goes in 18 and 36. 6 goes 18 and 36. But Eduardo's correct. We want to go with the biggest thing we can pull out. And the biggest thing we can pull out is the 18. So he's correct with that. However, we could have done this a little differently. Yes, Arturo?
9x.
Okay, again, 9 and 6 are not quite as big as 18. We want to pull out the 18. But we could have pulled out a -18x. In which case, we would have had 2x minus 1. Now, I probably would have kept it easy and done the top one today. But just in case, multiple choice standardized tests, you're never sure what they're going to do. So just be prepared to factor out either one and keep up with your signs. Okay, as for number 5.
At this time, could we pick up sophomores A through L for makeup pictures or retakes for the lobby?
Number 5. I need help with number 5, and I'm going to go crazy if they keep doing this all day. Let me just go ahead and throw that out there. Thank you, Braxton. 8x to the 3rd. Okay, what would you be left with?
x6.
X to the 6 plus 2 what? Okay, and then what? Minus 1, and that's beautiful. I'm glad he remembered his rules of exponents. For those of us that don't, we add our exponents. So 3 plus 6 is 9. 3 plus 1 is 4. 3 plus none is 3. So he did a terrific job. In fact, he did so good, we're going to give him 2 for that. Okay, and now for number 6, -3. Yes, dear.
5x.
Now what?
You have x2 and y2. Or x squared and y squared.
Okay, and then what?
Then you have plus 5xy.
Plus 5xy?
Right, plus 2xy.
Okay.
Sorry.
That's fine. And then plus what?
5.
Perfect.
Sorry, I'm a bit brain fried from yesterday.
Okay, so if we were to check ourselves and redistribute this back out, we would have 5x plus x squared would be x to the 3rd y squared, so I know we can interact with this term. 5 times 2 is 10, x times x is x squared, so 10x squared y, that's correct. And then 5 times 5 is 25, so 25x. So that is perfect and beautiful. If you're trying to get your group some points, you know we're going to do 7 through 12 tomorrow. So go ahead and you could go ahead and get those done before tomorrow to help your group out. Especially like number 10, that's an easy one, or so it seems. Sometimes those are deceptive. Okay, let's go ahead and to your notes. We handled piecewise. There's a bunch of junk in the middle we're skipping. We're going to come back to it tomorrow. And we're going to go to page 37. It's 2 from the end in your packet. And it says graphing linear inequalities at the top. Graphing linear inequalities. Now the reason we're skipping to this one is it's probably the easiest section out of what we had left in chapter 2. So we already tested on the first half of chapter 2. We did 2-1 through 2-4. Our next test, which should be next Tuesday, possibly next Wednesday, but I pray Tuesday or else we're behind. Behind some more, and I don't want to be behind. What was I saying? Oh, it's 2-5 through 2-8. We've already handled 2-5. That was piecewise. And this is 2-8, the graphing linear inequality. And I believe you will love it, but I've been wrong before. Believe you will love it, but I've been wrong before. Okay, so when we graph a linear inequality, it's really just like graphing a line. So if you want to have out colors, I'm going to use some colors. But this should be an easy day, we pray. Okay, so the first blank is inequality. And it should say an inequality. An inequality resembles a linear equation, but with an inequality, you have what kind of symbols instead of an equal to? What are my 4 other options besides an equal to? And Kelsey's group got another point. Greater than, less than, greater than or equal to, less than or equal to. So that's all that's changing. However, does that change how we graph things? No. So, general reminder, so if we see negative 3x minus 2, if this was y equals mx plus b, it would be y equals negative 3x minus 2. So we're going to put our intercepts at negative 2 on the y-axis. I'm going to put my intercept at negative 2 on the y-axis. I have some still who, bless their hearts, are in Algebra 2 with trig, and they're still putting their intercepts on the x-axis. That b goes on that y-axis. Okay, my slope is 3 over 1, so I'm going to go up 3, and then to the left 1, up 3, and then to the left 1. And as we talked about before, I'm a little slow with my negatives. So I always have to think it through as a negative line is supposed to lean to the left. So I know I'm correct. I put it at negative 2 because my intercept was at negative 2. On the y-axis. I put it at negative 2 on the y-axis. And then I counted my slope of 3 over 1.
I'm sorry, the numbers
You're good.
here just look like dots.
They do. I just counted down 2 dashes.
And you went up 3 and over 1?
Yes, because my slope was negative 3 over 1.
Now we have sophomores, M through Z.
Okay. Now, from here, life should be super easy because you're like, Miss Compton, we just graphed the line. Like, I know how to do that. I've known how to do that, I pray, since before you met me. But we were graphing just as if it was an equal to. Our problem is not an equal to. Our problem is a greater than or equal to. anytime you see an equal to, you get to do a solid line. So when we connect the dots, we are actually going to connect them with a solid line. But if this was a simply greater than problem, when we connected the dots, we would want to use a dashed line. So if I were to make a note of that to myself, I would say less than, greater than, you use a dashed line. And then if you're doing less than, equal to, greater than or equal to, you get to connect the dots with a solid line. So it kind of reminds me of the open and closed circles that we just handled. It's showing you in the graph, I understand what inequality I was given. Okay, and the sad news is we're not done from here. Because what we've graphed is the line y equals 3x minus, negative 3x minus 2. But our solution set is supposed to be greater than that, anything greater than that. So we're going to end up shading above that line, so over here. So on your paper you can color ugly like me, or you can take your sweet time and color it in. I do not care. It does not matter. Greater than, you should shade above it. Less than, you would think I shade below it. That makes natural sense. But if you're having a blonde moment, because God bless us, we all have them, you can always test a point in the region you think you should shade. So I do this a lot because I start to question my own sanity. So for instance, I see positive 4 comma 0 is in my solution set. That's one of the points over here in this shaded region. So I could seriously plug in a 4 for x and a 0 for y and make sure life is correct. So if I plug in a 0 for y and a 4 for x, because I'm using a test point of negative 4, 0. Not negative 4, it's positive 4, Miss Mom, thank the Lord. Okay, so I picked a point randomly. You can pick any point in this brown region you like. I just picked up what I thought was an easy one.
How'd you get the blue?
I just picked it.
Oh, the 0.
So I literally plugged in for y, I plugged in 0. For x, I plugged in 4. And if I continue to solve this, I would say 0 is greater than or equal to negative 12 minus 2. Well, yeah, 0 is greater than or equal to negative 14. So if that statement makes sense after you plug in your test point, you know you've shaded correctly. Let me say that again. So Will shaded. He's questioning his own sanity. Did I shade correctly? I think I did, but I'm not sure. He can pick any point in this shaded region, plug it into his inequality, and if it makes sense with his final statement, yeah, 0 is greater than negative 14, then he knows he's correct. Does he have to do the test point? No. Am I always going to do the test point? No. But when you question your own sanity, it's nice to know there's an easy way to check yourself. Okay, let's go deal with number 2. It says x minus y is less than x minus 5. Again, I'm graphing just like I would a normal linear equation. So I go put my intercept at negative 5. 1, 2, 3, 4, 5. Because if this was y equals mx plus b, then I would know my m is really 1 and my b is minus 5. So that's why my intercept is at negative 5. My slope would be 1 up 1 over 1. And then once I've graphed my line, just like old school, I put my intercept at negative 5. I counted up 1 over 1. Life is good. It was just like normal. But this problem is just a less than. It is not a less than or equal to. So when I connect the dots to make this line, I need to do it with a dash. And that way that shows the other math person or whoever's looking at your graph, that shows them what inequality you're dealing with. It shows them it must just be a less than, not a less than or equal to. Okay, since it was a less than, where would you assume we would shade? You assume we would shade above the line or below the line? So you assume we would shade down here, right? But again, and we'll do another test point on this one, you can always check with a point in that region, in that shaded region. So I colored it blue this time. I think it's easiest to pick a point either on the X or Y axis, but you can be weird and pick one out here. It doesn't matter. So I'm going to pick 6, 0 this time. I think it's 6. It might be 7. 1, 2, 3, 4, 5, 6, 7. 7, 0. Natalie's right. It's hard to read this one. So I'm going to pick my test point of 7, 0. Again, I just like to pick ones on the axis. That way I'm plugging in a 0 for one of them. So since we had y is less than x minus 5, I'm picking 0 for y. I'm picking 7 for x. Is 0 less than 2? Yeah, it is.
So how do you get that again?
So I just pick any point I want over here in the shaded area, and I genuinely just plug it in. I plug in that number for the x.
Where'd you get that?
Right here. But you could pick
How do you know that? Just pick anyone.
anyone in the shaded region, any of them.
Okay.
I just like to pick ones on the axis because then you get to plug in a 0. Okay, so I picked 7, 0, so I plugged in 7 for x, 0 for y. 7 minus 5 is 2. Is 0 less than 2? Yes, it is. And again, you have to do a test point every time. No, I'm probably not going to do any more from here on out. But when Kelsey questions her sanity of, can I shade correctly? Did I do this correctly? You can always shade. Now, you know life is about to get a little more complicated. Because on number 3, bless it, they didn't put it in what we normally would have wanted. It's not in y equals mx plus b. So we're going to have to rearrange that equation. So let's look at number 3. Life's not as good. We need y on one side, all the numbers on the other, just like you normally would when you graph.
At this time, could we have juniors?
So let's subtract x.
L.
Did you say that?
For makeup pictures or retake.
You did?
A through
Add a
L.
point.
Thank you.
I was trying to get what you said. Yes. Yes, go. So I have 2y greater than negative x plus 6. And then I still don't have y by itself, so I'm going to have to divide by 2. And I end up with y is greater than...
Okay, hang on.
Yes, dear.
You lost me.
We're rearranging the equation for y, just so we can graph it like normal. That way it's in y equals mx plus b.
Move the X over.
So I move the x over, and now I'm going to divide by 2 so y can be all by himself so we can graph it.
Oh, so just go all by itself.
Yes.
Okay.
Okay, well I know negative 1 over 2 is negative 1/2, so it's negative 1/2 x. Let me say that again. I know negative 1 over 2 is negative 1/2 x. I know 6 over 2 is 3. So I now know to graph the line negative 1/2 x plus 3. I keep wanting to give you points, and you keep not getting them. Why?
Oh, okay.
Okay, so we got negative 1/2 x plus 3.
3 on the, what's it called, on the y.
I put 3 on the y-axis because that's my intercept. Now I down 1, right 2, and that's how your group got a point. Down 1, right 2, down 1, right 2, down 1, right 2, up 1, right 2, up 1, right 2. Get more. Up 1, right 2. Fix it. Up 1, right 2, 1, right 2. Okay, but now I'm at this point. I've graphed my line. Are there any questions about graphing that line? I graphed my line. Now, am I going to connect it with a solid line or with a dotted line?
Solid.
A dash.
You use a dotted. Why do you use the dotted?
Because there's no line underneath it.
Because it's just greater than, and Eduardo said it first, so he can have the point. So, I connect it with my dotted line. Okay, and then since it's greater than, where do we assume we shade? Above, and that's how you can get one other point right there. So we shade above. Hot dog. Again, if you're questioning your sanity, now would be a good time for a test point. But you and I have other stuff to do today, so we're going to let it go and move on to the next one.
Can I pick one?
Can you pick one? It's on the back.
You're not going to test it?
Oh, no, I'm not going to test it. But if you wanted to, it's not a bad idea.
Why not? Like, is it mandatory?
No, it's not mandatory. It's just if you're questioning your sanity. You like to make 100. Who doesn't? Okay, you knew Miss Compton was inevitably going to make a mistake when she copied and glued everything together, right? We're not going to do this one next. We haven't talked about absolute value today. Why would that be our next problem? That doesn't make sense. We're on to number 4. It's on the next page.
I'm sorry, I have one more question.
You can have a question, maybe.
Okay, so if it's greater than...
The time juniors M through Z. The main lobby for picture retake or makeup.
Kind of how it's going today, isn't it?
So, on the line, if it's like this, and it's greater than, you shade above.
Yes.
If it's less than, you shade at the bottom.
Yes.
So what if it was this way?
Then still the same logic of above and below. Just think about where above would be and where below would be. And if you're going to start questioning your sanity like you're going to on 4, then a test point would be a good idea.
Is it greater than this way?
Greater than is the one that does, less than looks like an L. Brister, you're backwards.
Okay.
Backwards for her. Yes, but you're sitting across from her.
Yeah, I know. This is less than.
Yeah,
Less than
L.
is left.
yeah.
Makes
Page.
it L, right?
It's not on the back of that one. It's the very last page.
Thank you, Mr.
Yeah, look, I stapled on. So find it. Okay, I think I stapled all yours poorly. My bad. Can you find number 4 wherever it is? Table 1, you're killing me. I'm trying to not take points away, but you're killing me. Okay, number 4. We've only got 3 left, and then it's your turn with a checkpoint. Okay, life is about to get harder with 4, 5, and 6. We'll talk about 4 in a second. For 2 points, does anyone know, how we can make life more complicated with inequalities, which is what we're going to do on 5 and 6?
Oh,
No fences required.
alright, cool. Look.
What funky thing happens with inequalities, and it drives you crazy?
Know why? I'm just playing.
No one has any idea?
Hold on, wait a minute.
It doesn't got a thing where you go up and over. Right.
We're going to graph it.
Slope,
Okay.
Stop.
Then let's change it to 1 point, and I'll give you a hint. It happens when you multiply or divide by a negative.
You can't graph a negative.
Flip it the sign.
You have to flip the sign. And every group can have a point, because I know I heard it from 3 and 5, but I'm not really sure about who else. Every group can have a point. Yeah, that's what I thought. I'm at 2, 3, 5. Sorry. Can't count.
Hey, what's that?
Okay, so, and that's going to come up on 5 and 6. That's going to come up on 5 and 6. Okay, so let's go ahead and get 4 out of the way. So x greater than or equal to 6. With your arm, hold up what that line looks like and get your group a point.
I got you.
Table 2 has a point. Table 6 has a point. 5 get a point. 1 can have a point. Patrick, your group can have a point too. Yes, Paige, you can have a point too. Okay. Bless your hearts. If someone doesn't put it at 6, so 1, 2, 3, 4, 5, 6. And I know I actually get to do a solid line because it's greater than or equal to.
Wait, what?
It's a solid line because it's greater than or equal to. Now, we've got this problem of, and that's what me and Natalie are already debating, where do you shade it? Where do you shade it? Because now where is greater than,
Right.
where is less than. So I'm assuming greater than is to the right. And I'm assuming correctly. But again, if Gracie is concerned and she wants to check herself, it's always a good idea to go back down one. It's always a good idea to plug in a test point. Always a good idea. Ask me, Paige.
Like when it's just x greater than or less than a number, like you always go to the opposite sign that it's open to shade it.
So we're taking it now?
You could.
This is how we did it.
Okay.
We always tested if the line did not go from 0.
Okay.
We always tested.
Let's test it. Let's test. It won't kill us.
And then
1,
what
2,
we
3,
did
4, 5, 6.
Is we always tested with 0, and if it was a true statement, you shaded to the 0. If it was a false statement, you shaded away from the 0.
So Miss Brewster has another option, which is a good one. She's like me. She likes plugging in zeros. So I picked a test point of 7, 0. But if we were to pick a test point that's not in our region, like if we tested 0, 0, wouldn't we expect it to fail?
Yeah.
So we can do what she wants. So if we plug in 0, is 0 greater than or equal to 6? No. So we know 0, 0 is incorrect. So therefore we did shade the right region. But if we plugged in my test point, we would have 7 is greater than or equal to 6. Well, that's true, so we shaded in the correct region. So back to, I like to plug in a test point from my shaded region. Miss Brewster goes with the origin every single time, and then she knows if she's right or wrong. She's like, oh, it's supposed to be false. I didn't shade there. It's supposed to be true. I did shade there. So that's an easy thought, and that would be an easy plug. Okay, so 5 and 6, already beware, we're going to have to flip the sign. Are there any more questions about 4? Okay, 5 and 6, beware, we're going to have to flip the sign. So yes, dear.
What is the 7 and the 6 for?
Oh, I was testing the point 70. So I plugged in 7. So the problem said x is greater than or equal to 6. I plugged in 7. Is 7 greater than or equal to 6? Yes, it is.
So we have to write that?
No, not unless you want to. If you did Brister's tech point, you can, or if you just know you're right, that's fine. I just like to test it out, so does Brister, because I like to make sure I'm 100% right. Okay, on number 5, we're not in y equals mx plus b, so we've got to move over that 4x first. So we'll have negative 3y is greater than negative 4x plus 12. We've got to get y all by itself, so what do we need to divide by?
3.
Okay, but the problem is when we divide by that negative 3,
Will said that.
so many said that, we have to flip the sign, and y'all been talking a lot while I've been talking. I'm just trying to ignore you at this point. Okay, so I would have to have y, but I flip the sign. Instead of greater than, it becomes a less than sign. Do not go crazy. So I went over this in discrete, and they went crazy, and they tried to flip the sign all the time. You only flip the sign if you multiply or divide by a negative. We divided by negative 3, we get to flip the sign. Okay, well, negative 4 over negative 3 is positive 4 over 3, so my slope is 4/3 x. 12 divided by negative 3 is negative 4. So I need to graph the line 4/3 x minus 4. Okay, so I go down to negative 4. Negative 1, negative 2, negative 3, negative 4. I put my point. My slope is 4/3, so I count up 4 over 3.
Why'd you circle the...
Oh, just to point it out that it flipped. Okay, I went down to negative 4. I put my intercept. I went up 4 and over 3. I'm going to go up 4 over 3. I don't think I have enough room. Let me
Why'd
see.
you put your dot at 3?
I put it at 4 because it was negative 4.
Yeah, it's just so small you can't tell which one's
Yep,
one or two.
it is. Okay, but it's only a less than sign, not a less than or equal to. So I'm going to do a dashed line. And then since it's less than, I should shade where? I should shade below. But now let's talk about this. What would have went wrong if Kelsey didn't flip the sign? When she shaded, she would have shaded the wrong region. She would have shaded, it would have stayed a greater than sign, she would have stayed above, and so her answer is incorrect. I know that seems silly and trivial, but it's true. So if you don't flip the sign when you divide by a negative, you end up shading the wrong region. Or even worse, you flip the sign for no good reason, you still end up shading the wrong region. So you have to be very careful with the sign because it tells you where to shade. Okay, are there any questions on 5? Then I need help with number 6 to try to get you some more points, and then we've got a fast checkpoint.
I'll help you.
Please.
Okay, you're going to bring 6x over...
Okay, so I subtract 6x from both sides.
Yeah.
I've got 4y is less than or equal to negative 6x minus 24. Now what?
Divide by 4.
Divide by 4, now what?
And then you're going to have... What's the...
Y is less than 2/3 over x minus 6.
I agree with the minus 6, and you're going to get a point. And it's going to be 3 over 2. Thank you. Okay, so you can have a point. So 6 over 4 reduces to 3 over 2. 24 over 4 is negative 6. So we're going to negative 6. Are there any questions about that?
No, plus negative 6.
We go plot negative 6 on the y. 1, 2, 3, 4, 5, 6. Down 3. Right 2. Your group gets a point. So yes, go down to negative 6 because that's what that intercept is. And then I go up 3, left 2, up 3, left 2, up 3, left 2. Well, I know it's negative, so my line needs to lean to the left. And then I'm so excited. Oh, I can go again. Up 3, left 2, up 3, I'm so excited because it's a less than or equal to. So when I connect the dots, I can use a, Kelsey said it first, solid line. You get the point, Kelsey. And then since it's a less than, where should we assume we shade?
Bottom.
Okay, where is bottom? Is this up below the line or is this below the line? This is below the line. Again, if you start questioning your sanity, though, there's not a bad idea to use a test point and make sure you're not crazy. Not a bad idea at all. Okay, are there any questions about this? Then clear off your desk. You don't need anything except your pencil. Here's your checkpoint on it. Can you do it yourself? And if not, it's going to be a long day. If you can get this done before you leave the room and I approve it, that means you have no homework. If not, you better have this done and it's perfected by tomorrow.
Only just one question. Yes, Harry. Yes, only one question.
Okay, I was going to move all the groups up with points, and now I'm having a little debate in my soul. So I need to see you work on this checkpoint, get my approval, and we've still got 10 minutes. I gladly can move you up or down. Based off the stupid questions I got, but I appreciate you helping me out. Bless you. Thank you.